Okay, let's start. Good evening, everyone. Welcome to second live session for the course Usability Engineering. My name is Neelarnab Dutta. I am a PMRF fellow from Department of Design, IIT Guwahati. So in this particular class, I'll be discussing the key concepts from week 2 lectures. Okay. The idea is to clear your doubts through this live session, and the deadline for the week 2 assignments already over. However, the by clarifying these concepts, I'll be helping you to understand the assignment questions and what could be the possible solutions for those answers. Um, so have you attended my last class? Yes. Okay, so I want this session to be a bit interactive, so you can interact with me directly, and also you can use the message box to chat with me during the live session. So in the last class we discussed about the the various the usability parameters, which were learnability, memorability, efficiency. So all the seven key features of usability, and also we discussed about the Garrett model, which is the five layered conceptual model, how UX design uh, happens. Okay, so if you have any doubt in from the previous session, you can feel free to ask any question. Okay, okay, fine. Okay, so in the second week of usability engineering, what you were taught is about how usability is related to software development. Okay, so let's start by uh, giving some historical information for you. So back in 1960s, okay, what we called software development are basically simple applications. So we used to have simple applications. So imagine we used to have simple calculators, okay, and we have used to have buttons. Okay, so in terms of software, we used to develop, like the scientific community, the computational computing professional mostly engaged with this kind of embedded systems development and the related software development. So the nature of these softwares were very simple, and most of these softwares uses simple languages like C or assembly languages. So the nature of the languages and nature of the development process was also very simple. So one can directly work on a problem by simply start developing, okay, a product. However, if we look into today's scenario, or since 1980s, we came to an era where computers were no more strict like restricted to a department or to a lab. So we used to so people get access to computers in their homes. So user the user community diversified. So now what we have as application are much more complex, and they are not easy to develop by simple procedural language like C or assembly languages. And most of the application that we develop in this particular era are object oriented, oriented, and they provide multiple functionalities and features. Okay. Now, back in 1960s, for developing simple applications for like a calculator or small music players, the interface we used to have are simple graphical user interfaces, which are probably 8-bit displays, and then we used to have tactile buttons. So the nature of interactions were also very limited to only tactile button press, and the display what we used to have is only for visual and displaying information. Okay, only for displaying information. But in today's era, if you see, like we used to have smartphones. Okay, so you have a multimodal interaction. You can, in a smartphone you used to have a touch. Okay, we used to also have a type interface. Okay, so a lot of multimodality emerges in today's uh, interactions and interface development. Okay, so what it was realized back in 1990s is that a software development process can be made systematic. Okay, so this systematic use of this systematic methodology and techniques allow the scientific community or the computing professionals to develop much more complex uh, applications, complex products. Okay, so what I mean by complex software systems is that a complex software system always have a overall objective as a software system, and which again comprise of multiple subsystems. For example, if you want to develop a mobile application, okay, or a like a application for controlling a drone, okay, so what we need is probably first a communication handler. Okay, so I'm giving an example for a drone. Okay, so you have a drone. Okay, so you have a quadcopter, and you are controlling this quadcopter using a smartphone. Okay, so this is a smartphone, and you have a drone. Sorry, drone. Okay, so the nature of the application development is nowadays are modular. Okay, so the smartphone will the application will have the communication handler. Okay, which will probably handle the IR communication or radio signal communication. Okay, then you used to have uh, the event handler. So event handler means how this particular thing has to move. So whether you need to move it forward, backward, or it should be in autonomous mode. So all sort of events will be handled, like forward movement, backward, so exam, etc. Similarly, there can be other things like if your drone have some capability of capturing images. Okay, so probably you want to control those image capturing features from your smartphone. So image capture. Okay, so then you again have some subsystems. So the entire software development in a process can be break down into subsystems and then sub-subsystems, and this can be achieved in a systematic way. So in an organization, one can divide the team. One team can work in the communication handling part, one team can work on the event handling part, another team can work, and later they can actually collaborate and combine the overall architecture to fulfill the overall objectives. So this kind of software development allows inclusion of high level languages like C++, Java. Your Android programming is again based on Java. Okay. Okay, so this particular class is not about programming. I'm just giving you an example so that you will get to understand what I am trying to explain. So back in 1980s, when uh, the first batch of computers exist and they were available for common users. Okay, so the computer engineers, they try to develop applications. Okay, and then they realize, then based on user needs, okay, there are multiple applications one may require, okay, for operating a particular computer. Okay, so initially for computer scientists, probably DOS was used, Linux based systems were used. But as we come down to less technical person, then we need to provide some sort of user interface where we need to facilitate a common user with a mouse, a keyboard, and a CPU and a monitor. Okay. So with the introduction of new input devices, your applications also get more complex and more modular in nature. So there it was realized that instead of earlier adoption of simple model for simple model for software development, what it was realized is to to consider something more systematic, methodological, which will help in developing and monitoring the overall software development process. Okay, so an early adoption of such a process is known as waterfall model. Okay. Okay, so do you know why it's called waterfall model? Yes, Pavan. Okay, so like waterfall, here the process allows only a forward movement. So it's like a waterfall where process, so water can fall from top to bottom, but it cannot return back. Okay, so which is not allowed. Okay, so that was not actually the intended purpose of this particular process. However, so initially the process was a linear process, which is like a requirement stage, then design stage, then implement stage, verification stage, maintenance stage. Okay, so this particular process, the model of software development was a linear process where, for example, if you want to develop uh, a mobile application, so back in 1980s, like when someone tried to develop a computer application, they first come up with set of requirements. Okay, so once requirements are finalized, so they finalized and they considered it as a checkpoint. Okay, like, okay, we have this set of requirements, we freeze the requirements. Now let's move to the next stage, that is design phase. So during the design phase, based on the frozen requirements, they design a particular application, and then they again fixed the design. So then they fix the design. Okay, so they evaluate and they fix the design. Next, what happened? They try to implement it, and when they implement, they choose a user community and they implement. So this is more for an organizational level practice where implementation means they commercialize a particular product, and once the particular product is successfully available in the market, they say we are successfully implemented. Next is verification. That means they gathered customer inputs. Okay, are they satisfied or not? And if they say they are satisfied, then it's okay. But if they say they're not satisfied, there are some bugs, then they repeat this entire process again. Okay, and they maintain. If it is a, if it is a good software, then they uh, put time in maintaining and make provide a service for maintenance of the particular application. Okay, so what do you think are the limitation? Okay, limitation or the advantages of this particular process. Okay, okay, saw your answer. So basically, this was an improvement over the traditional approach where one straight away go into the design and implementation phase. Okay, earlier, for example, you people, if you're from computer science background or if you're from electronics background, if you have to do a school project or class project, you may realize that you straight go choose a problem and start developing something, and then you make an application or make a some device. So which is actually okay for student level projects. However, that's not exactly how a systematic way of software development happen. So this is how earlier the computing community tried to develop products. So like the school, like school kids, they used to also develop straight coming to design and implementation. But when they realized that the user community now got bigger, so they start gathering requirements. So they introduced new stages. However, the limitation of this particular process was that there was no intermediate recursive change in the design. If during the implementation phase the design faces certain issues, or during the design if someone recognize a new requirement, they cannot go back. Okay, so one needs to entirely follow this particular pipeline of activities in the organization, then only the next version of the products can come into picture. So that is basically the disadvantage. Okay, so this particular way of development is also known as stage gate design process. Okay, so have you heard about stage gate design process? Okay, okay, so let me introduce you to two uh, important concepts on the software application design process. They are also applicable for product design process. But for today's session, I'll be talking from the perspective of both software as well as product. So, what I discussed previously as a waterfall model, although it's a name of the model, it is basically a representation of a stage gate process. So, this stage gate process um, is more popular among the engineering community, and waterfall model is more popular among the software development community. However, they both mean the same thing. So basically, if you see in a stage gate process, we do not define what are the stages, but rather we represent a conceptual design process. In waterfall model, we have five stages like requirement, design, implement, evaluation, and this. So this is like a fixed process, and the type of this particular process is called stage gate process. What do you mean by stage gate? Is that we have stages. Okay, after each stage, we used to have a gate. So that gate is the checkpoint. Okay, for example, in the waterfall model, stage one is requirement. Okay, so once we have identified the set of requirements and we say, okay, done, like we are happy with the set of requirements. Okay, so these are appropriate. So one, it is verified. So requirements verified. Then you move to the stage 2, which is in the waterfall model case, it is the design. Now there's no way you can go back because there's a gate here. This gate is a checkpoint. So in the second phase, what we do, we come up with various designs. So we have multiple designs. Okay, and we choose, okay, this is a particular design which we selected because of this many reasons, because of it satisfied that particular matrix, it satisfied those requirements, so this is the best particular concepts. So you freeze them. So you freeze here the design. So what we freeze here, the requirements, we freeze the design. So we freeze the design here. So likewise, next is implement. Then we have another gate. So this particular way of developing is what we call is a stage gate process. Okay, so this can extend. Okay, and the drawback, the advantage is that this make the particular process very systematic. So it is very easy to manage for simple projects. But in a complex projects which involve multiple modularity, which involve parallel processing, stage gate approach is not very ideal, especially for software development. Okay, so there's another process which is called spiral design process. Okay, so have you heard about spiral design process? I mean, these are very popular terminologies among the developer communities actually. Okay, I think you feel free to chat or use the mic to directly communicate with me. Okay, so it will be helpful for me also to conduct this particular class in an interactive way. Okay. Okay, so and in case if you have any doubts, any question, please ask me. Like, please stop me intermediately, and you can just, yeah. Okay, okay. So spiral design is basically a a version of stage gate, but it is like multiple stage gate. So from here to here, this is one particular stage gate process. So basically we used to have stages, then gates, stages, then gates. Okay, so I'm not very, okay, okay, hopefully it's easy to understand. Okay, so this is basically, if we stress this particular spiral design, when you stress it, it will again represent one linear stage gate process. And this particular design process generally is useful for software development where you release a version of a software with time. So basically the spiral design process have temporal component in it. So when you say version 1, you said, like, for example, in 2016 you release version 1, then you go through another spiral, another stage gate approach. Okay, it has similar stages. Okay, so likewise, and then the next person you release in 2018. Okay, likewise again you continue the same process and you release in 2023 another version. So generally what happened, for each of this cycle, which is spiral in nature, we have a new set of requirements and we have a new implementation. Okay, implementation validation. Okay, and then you again improvise your requirements, and then you move ahead and again you implement something, and verify, and when you realize the new requirements come, then again you do it. So this way of development or design process is what we call a spiral design process. Clear? Okay, I'll give one example so this will be much.
Yes,
Yes,
sir.
sir. Okay. Okay, so what are the advantages and disadvantages? So we need to understand this. So advantage wise, the spiral design allows release of versions without completion. Okay, so imagine you have a software and every year you extend the software. So you have version 1 released in 2016 and it has certain set of it meets certain requirements of user, and that version is released in 2016. Again the software get improved, so you have improved features, functionalities, and you have version 2 in 2018. So this particular way of development is very much useful for software development because here in terms of resource a company can sustain with the same sort of resources. So for software development you do not require machinery or do not require raw materials, right? So your development does not uh, l- get limited by the availability of raw materials or machinery. So it is mostly human resources, and if you have employees, so if you have employees like 500 employees within your organization, so using the same resources, human resources, you can probably develop. Okay, and for softwares actually ideally this works because you cannot wait until you have the most appropriate version of the softwares because requirements always adds, and whatever version uh, you could develop in a year or 2 year time, you release that version with the limited set of features, and those which you feel like are underdeveloped you use those as beta features. Okay, so that's how it's been implemented in the software industry. Okay, a stage gate is more traditional where actually um, you have to meet the requirements within one particular cycle of product development. Okay, so if I say if you want to develop a product in such a way that the product has to reach 100% efficiency in the first run, then you choose something like a stage gate process. Okay, however, if it is okay for your product, like if your product achieve 40% effectiveness or efficiency, whatever you say, and in the next year it becomes 60%, then 80%, and slowly you try to make a more useful product. So in for those kind of development generally we use a spiral design process. So whether it's for product or software, we depending upon the nature of the development or the output quality, we determine which particular approach we'll take. Are clear? Any doubts here? Okay, so let's take some example. Okay, so I think it will be helpful for you guys if you I know, if I give some example and you uh, try to implement your understanding of these concepts through this example. Okay, so let's understand the difference between software development and product development. Okay, so just now we learned two processes, right? One is the stage gate and the other is spiral design and stage gate. Okay, so out of these four products, one is a car, BMW car, one is a SolidWorks CAD software. This is a CAD software. This is a aircraft, which is Tejas aircraft for Indian Air Force. And then we have Windows 11. So which product do you think is appropriate to go through a stage gate design process, and which products do you think is appropriate to go through a spiral design process? And you need to tell me why. Yes.
So SolidWorks and Windows 11 will go for spiral design.
Yes. Okay. And the two other will go through a stage gate process, right?
Stage gate process.
And why do you
Yes,
think?
sir.
Okay, so what is the reason behind it?
Sir, as you explained, we need to update to make product more useful, as there is a lot of opportunities I feel in software products where we can uh, update lot of things for user. So I feel
Okay.
that is the main reason here.
Okay. So yeah, you are partly correct. So one important criteria here is that, see, as I told you, you want to achieve 100% efficiency when you have set of requirements. So for those products, whether it is software or hardware or product, if you can commercialize a particular product without 100% efficiency or accuracy, then those products only go can adopt spiral design approach. For example, a car involves the exterior design, the engine design, the sitting, okay, then the driving, the power train driving mechanisms, all this sort of modularity. So basically, in a car development, you cannot commercialize a particular car without achieving you 100% efficiency in each of these design modularities. So in terms of exterior, you need to make sure that you actually have a flawless chassis. Okay, so car is basically having the outer surface is basically developed on top of a engineered chassis. So you need to make sure that you have a 100% working chassis. Similarly, the power train, the engine performance has to be 100% to pull six people at particular top speed. Okay, because you already mentioned this information in the specification that your car has to run with that much bhp of power. So basically you cannot compromise when you are actually delivering your product. Okay, one reason is that. Second reason is, for the same reason, in software development, what happens if you see SolidWorks? So do you know what is SolidWorks? Okay, so SolidWorks is a 3D modeling software, which using which you can actually model a 3D model, a virtual 3D model of anything, like any product. Okay, so SolidWorks have been in the industry for like a decade, more than a decade, and like since 2008, you have a version 2008, 2009. So every year SolidWorks release one version. Okay, so till 2023 we have new versions of SolidWorks. Same with Windows 11. So in this particular set of development, what happens? We only design a software for certain specification, which we never say that these are like 100% of the entire software. Okay, so even today, SolidWorks did not have attained its 100% capability, and no one knows what is its 100% capability because the requirements evolve, and always there's a tendency to make some changes, whether if not from functional point of view, then it will be from the ease of use perspective. Okay, so constantly uh, the softwares developed over time, and sometimes softwares fix bugs. Okay, so software bug fixing is different than a mechanical hardware bug fixing. So hardware bug fixing is like one time job because those are rigid parts, but software bug fixing is always there are loopholes where engineers may fail to analyze those prior to their release. So later during their launch only, or during the use case in user involvement only, the developer community come to know about those issues. So for various reasons, for all such various reasons, software development always happen in a recurrent manner. Okay, so because of that, we need to involve multiple stage gate approach in a software development. Okay, so this is one aspect. The aspect is that 100%, here we need 100% result. We cannot sell something with 70% or 80% result. Here it is allowed, although we do not know what is 100%, but still, if you see 2010 version is 100%, then you can say 2008 was 70%. But again, in the new year, like in 2023, if you say 2023 is 100%, then you will then probably say 2010 was 80%, this was 40%. Okay, so that was one reason. The other reason was that the resource requirement for development. Okay, so in case of software development, the resource requirement is not like machinery or tools or any raw materials. It is only human resources mostly. Okay, so a company having a 500 employees, having 100 systems, and your licenses, software development licenses, can actually recursively design softwares. Okay, so that is a very sustainable design development model. However, in case of car, each car need new raw material, new design work, and new development planning from manufacturing point of view. So you cannot use, although you can use the same human resources, but in terms of raw material or in terms of other resources and machinery, you need to make changes in terms of molds, in terms of dies, cast. Okay, so that's the reason why when we develop certain products, we make sure that we um, make them in one go, and we try to achieve 100% of what it is meant for. Okay, am I clear?
Yes, sir.
Okay. Okay, so okay, so till now we understood like what are various software development processes. So in our first class we understood like why, what is usability engineering in a very simplified manner. Okay, and then we discussed about what are the components of usability engineering, and then we gave a brief about what are various stages of UX design. Then in the first few slides of today's lecture, I discussed about what is the difference between a software development process and a product development process. Now we need to understand like where usability come into picture in software development. Okay, okay, so to give this particular answer, we need to again go back to the history, and I'll not you know, I'll not tell you the history again, but I'll briefly summarize the aspects as I already told. Like historically, the user used to be only the computing professional. This is, I'm talking about 1960. Now in 2000 or in late 1990s to till date, the user is the vast human population. Okay, it's the entire human population. Everyone have access to softwares in these days. Like even kids used to operate softwares. Like okay, even the children's, even 2 year 3 year kids, they try to use mobile phone applications, okay, and they comfortably run various applications. So now the user, as we move ahead in time, the context of usability analysis also changes. Okay, so earlier, back in 80s, what we are talking about usability means we are trying to understand the how easy. So in the first class I talked about what do you mean by usability. Is like understanding the ease of use, like okay, how easy a particular interface is. So that means we are just investigating on the UI design part. UI means user interface. So in UI design, we process information, actions,
Inter
and interactions, right? So what happened? Like when we move uh, in time, okay, we realized like the user interface design and its usability concerns are not only limited to uh, a fixed set of information, actions, or interactions, but also there are dependencies that comes from users. So that comes from user profiles. Okay. So as when we consider user profiles, that means we have now a vast human population. Imagine you want to develop a banking application. Okay, so you want to develop a banking application like Axis Bank application. Now, historically, you will do a spiral design approach. You will set certain requirements. Requirements means based on the various tasks that are uh, available in banks. You probably would set certain requirements, then you design an interface, and then you try to analyze the usability of that particular interface. Okay? But in the current scenario, when you try to adopt this particular application for Indian, for example, for Indian scenario, what we'll see that we have the urban rural difference, we have then gender differences, male female, right? We have then age differences. So a lot of factors come into picture when we start designing the informations, when we try defining the actions, and when we try defining the interactions. And that's the reason why in today's era, usability concern also about the initial requirement analysis aspect as well as system evaluation. So earlier, when products were developed, the requirement analysis is mostly done by marketing professionals. So in an organizational, what we have, so we have a big organization. We used to have marketing, sales and marketing team, sales and marketing team. Then we have the design and development, sometimes called R&D also. Then you used to have the quality assurance, team. So this is just a brief breakdown of various human resources in an organization. So in a product development process, in earlier products, what happened, like the marketing people, they used to gather information from the market by reviewing competitive products. So they used to review competitive products. They do user study. They go and identify the requirements, and the requirements are then passed to the design team. The design team develops something, and they then implement, the organization implement them. Then the quality assurance teams check, those systems for their usability. Okay. However, that's not the case in today's era, because in this particular model of task execution, what happens, like by the time the quality assurance people actually evaluate something, maybe there is a new design requirement. They realize the design team already have finished their works, and they probably are in a different project. It's like a pipeline of projects. By the time they actually start analyzing, they are already in a different projects. Or when design teams are actually designing something and they identified a new requirement, probably it's too late for the marketing people, because they are also engaged in some other projects. So this never happens uh, in today's era, where one need a more usable product. Okay. So now it's the job of a designer to analyze all these three aspects in the design of a software product or any product. Okay. So when we consider designing a software, designing a software application or user interface, now the role or the scope of designer or scope of usability come here, here, and here. Okay. So that's what is represented in this spiral design process. Like every time we have a new stage gate for version 1, now we cannot have a linear process, which is like requirement analysis, requirement design, and implement and evaluation. Rather, we need to have a more holistic approach, where we need a design process where there are iterations between different stages. Okay. So there may be change of requirements, there may be during the design process, there may be change of design during the implementation process. So the designer needs to be ready for all such changes. Okay. So that's how usability currently is used, emerges within the software development process. Okay, so here's an example. Okay, what do I mean by uh, combination of these three aspects? Is that, for example, when you want to develop, for example, a medical product. Okay, suppose you want to develop a medical product. In previous way of doing uh, software design or product design, so usability only concern about the ease of use about this particular interface. Okay, and these data actually were collected separately by a separate team. Okay. Okay, but in current scenario, the usability as the scope of usability lies in requirement analysis, where you first identify the various users. For example, for a medical products, users can be, so by user I mean stakeholders. Stakeholders can be clinician, it can be patient, and it can be technician. Okay. So in earlier approach of such software development, what happened, the marketing people, they mostly fail to capture the actual insights from the actual user. So sometimes they fail to recognize the user. Okay, so that approach often give some wrong set of user requirements. Okay, so in current practice, a UX designer needs to do the contextual inquiry of a particular scenario, and he or she needs to identify the users. So for example, in this particular case, the users are clinician, so stakeholders are clinician, the person who will be using the particular medical device, a patient, so patient will be the person on whom the device will be used, and then probably a technician who occasionally will inspect the particular device in case the system gives some faulty results or it needs certain debugging. Okay, so when we try to gather information on the requirements, system requirements, we get requirements from its users, and that's the beauty of the current approach, where we concern about each stakeholder and try to understand their requirements in the software development process. So for example, for a clinician, user requirements, a clinician requirement will be therapy selection, configuration, application. So if this is a particular device which can provide a particular clinical therapy, so the clinicians has to be able to select a particular therapy, okay, configure and apply. Okay, so the design should incorporate the change in that. So you can see here is a mode button where the clinician can use to select various therapies. Similarly, the clinician should be able to monitor the runtime status of the system. So here runtime information means, for example, here the pressure indication as well as the elapsed time. Okay, also the time, battery level, so all those are important information that the clinician want to monitor during the therapy. Again, for the clinician, he wants to have all sort of records related to therapy, related to patient history. So those are some of the features which probably the clinician want to have in the system. Okay, emergency and fault recognition is again the clinician want to detect, so he should be able to have, so the system should have features where in case of any emergency or any fault, the system should indicate so what issues it faces. Similarity for the patient also, when he is not using actually, but since he is the person on top of which actually the therapy has been implemented, so he should be also able to not select, configure, and but he should be able to monitor this information, like which particular therapy he is undergoing, which what particular set of configuration he is applied with. Okay, so this sort of information the patient also should understand, or he should be also able to see. Similarly, a runtime status monitoring, then the log information, emergency, all these things also needs to be monitored. Okay, so for patient, probably therapy log and history informations are not important, so it is not his requirements. Similarly, for the technician, the set of requirements that has been identified probably is system debug and setting configuration. So he should be able to enter into a different mode which probably the clinician and the patient will not have access to. So this is like a restricted access, and accidentally the clinician and patient should not go into that particular mode. So that's how we need to design the interface, the UI, the interaction in a way that we serve the purpose of the requirements of each of these user profiles. Okay, so these come into picture when we actually try to define what needs to go in a UI design. Okay, So the goal of usability engineering is again to set a definitive usability goals. Okay. So by understanding the requirements of each of the clinician, we need to understand what can be achievable and how we can achieve that. So first, setting a set of definitive usability goals is what is required. Next is again, we already know about this, like designing the user interface. So based on the user requirements, we come up with various interaction ideas, and then we try to come up with the most optimized solution. And this is an example, like what is the best possible way to display information, interaction, and actions. Okay, so actions and interactions are a bit different. Interaction means how you engage, what are the uh, operand, what are the operators. Okay. Action means what is the overall action. So actions can be therapy, selection. Okay. Interaction can be push mode button. Okay. So in action is a broad level task. Interactions are the operation level task, and information is again all sort of information that appears on the in the graphical user interface. Okay. So after you do that, the next job of usability engineering is actually to understand how usable is the system. So how we do that? We do that by analyzing the system via user testing. Okay, so user testing is one way. There are various ways. So user testing is one way. Then you can do using various empirical techniques. So various techniques are available. So in this particular picture, I'm showing a system testing session where users are involved in the testing a particular device, and then again based on his feedback, okay, you define the requirements. Okay, so if in case those requirements are not met, you again iterate the requirements and again you redesign. So this particular cycle continues. Okay, so this is the approach how um, usability emerges into software development. Clear? Am I clear? So if you have any doubt, okay. Okay, so in the first class, I introduced you to various components of usability. Okay, so as we understand from here is that usability in today's scenario not only concerned about evaluating a user interface, but also analyzing the requirement as well as evaluating a particular system. That means we need to have the way how we get the feedback uh, after evaluating a particular system. Okay, so in the last class I discussed about the various components like memorability, learnability, efficiency, what else, effectiveness, errors, engaging, etc. Right, so those were like 7 components. However, if you see, we need a way to measure these components, because these are the components which define usability, but there should be some way to measure this, because memorability, how much the person memorize. Okay, because memorability means the person when he comes back after certain lapse, he should be able to recognize or recall the information for a fresh start. Similarly, learnability means for a new user, it should be easy to learn. efficiency means it should be fast. Effectiveness should means it should solve or the particular activity with accuracy, high accuracy. Errors means it should be free from errors. Engaging means again the person has to be emotionally connected and during the operation of a particular application or device. Okay. So nature of these particular constructs or these components are very much qualitative in nature. Okay. So in usability engineering, when we are saying like we have to iteratively uh, evaluate a system and then do the redesign, okay, recursively. That means we need some sort of empirical way to evaluate user interfaces. Okay, empirical means scientific way. So what do you mean by empirical? When something is measurable and when we repeat, okay, when we repeat the measurement, it should give the same result. Okay, so repeat measurable, okay, and scientific method. Okay, so the techniques through which the user interface should be evaluated has to be empirical in nature. Okay, so that's the reason why the scientific community or the design community, research community, they try to come up with different techniques how a user interface can be evaluated. So even if you do a user study, you cannot capture, you cannot judge something only based on video information. For example, if I capture a video information of this particular person, a lot of information can get missing. Okay, for example, we may not know what is the cognitive dilemma, or what sort of cognitive issues this particular person is facing when he's using this particular application. Okay, again, his actions sometimes may not be visible because they may be very minute, and on a video recording probably we may not uh, you know get the actual information. So there should be some way how we can empirically record those information about system testing and later uh, improvise or take those inputs and improvise our design and later check again on those parameters and whether we have achieved any improvement or not. Okay. So for that reason we need to measure human performance. Okay, so human performance measurement is a one way, okay, of doing it. So what you try to achieve here is that instead of analyzing a user interface, you are analyzing the performance of a person. So you are actually measuring him or her rather than measuring these components. Okay, so how? So there are different techniques. So there are ways like you count. So you count the number of keystrokes. Okay. So counting number of keystroke will give you like how long a particular action require, how much time probably a particular activity will require. For example, for this particular medical device, if I say like, okay, you need to set a particular therapy and then start. So probably you will understand like, okay, I need to click on this particular mode button several times and then probably select a particular therapy and then start. So number of keystrokes will be, for example, one, two keystroke and third keystroke. So in three keystroke, probably you will be able to start the particular therapy. So that's how we measure the ease of selecting a therapy, ease of starting a therapy. So this is one way. Okay. Then execution time. So how fast, so for example, instead of counting the keystrokes, we can also count the time. So if we give a user a particular this particular device and ask him to operate certain function, and we see how much time that person take at the end of the task, then we can analyze, okay, this particular task needs a lot of time, or this particular task, or interface is complex, that's why he is requiring so much time. Okay, so those are some way how we can empirically measure a user interface. And then number of errors, like when you give someone, like how much errors they make, that means you can improvise a particular interface based on the errors that it gives, and probably the less number of errors, the more the better is the user interface. Okay. Then probability of finding a feature. So probability of finding feature is again is a measure of probability. So for example, if out of 50 people, 40 people can identify a particular feature, so that means you can say like probability of identifying this particular feature is 40 by 50, which is like zero point 0.8. So 0.8 is the probability of finding particular feature. So these are the ways how empirically you can measure a particular feature in a user interface. Okay, so there are different uh, ways how we can measure. Okay, so basically, what we are trying to do here is empirical study of human-computer interactions, which is defined as the study of complex tasks involving computer processing and human cognitive processing. Okay. Uh, See, designing a user interface for a designer is not only just computer processing. It's also you need to design in such a way you reduce the cognitive load, okay, of a user. Okay, so the design has to be done in a very effective way, so that the interface gives less cognitive load and it use the optimal computing power of that particular system. Okay. So for example, what do you think what do you think are the different ways how we can evaluate a particular feature, like selecting, for example, here's the Amazon website. Okay, so in Amazon, we always find some item and purchase based on our requirement. So in such cases, like what is the optimal way how we can actually do a particular search. Okay. So here we can adopt this particular ways, like number of keystrokes. Okay. So for example, first you type here SHIRT. So identify, you want to buy one shirt, and you try to understand like how much time one particular person will need in the in navigating through this particular interface. So what the particular person will do, he will use this particular interface, and the one way is like he will type this particular item name, like for example here it is shirt. So then you will have a list of shirt, then there will be menus here, where okay you can select uh, uh, all the shirts which got more than 4-star rating. Then you have certain shirts available, then you can select one of them. Okay, so this is one particular approach. Okay, see the number of the how we are measuring it. We are measuring it by first identifying the number of keystrokes that this particular person make. So he is typing 5 times here, SHIRT. So there's a time, like time that has been elapsed in this particular action. Then he go here and select a particular filter, and then he select something, and then he buy. So in all these keystrokes, okay, you count the number of keystrokes and determine like how much effort this particular person will need, a particular action will need, to select one particular item from a menu. The other way of doing it is also like go to menu all, then from the all menu probably you will get apparel, then men, then shirt, and then you again come here, okay, and then enter into this particular page and select a shirt. Okay, so in the same website there are different ways how actually one can navigate and search particular item. Okay, so you need to identify uh, by counting the keystrokes, like which is the most appropriate way or which is the faster approach to do this particular activity. Okay, so that's how counting number of keystrokes will help in identifying the measure like efficiency. Okay, so there are different techniques which you will be taught in subsequent lectures. Okay, so you will come across in subsequent lectures about various techniques which will be used for measuring these initial qualitative components of usability. So here, by using keystrokes and execution time, we are actually capturing information on the efficiency of the interface. Clear? Okay. Okay, so again, one example here. Okay, so here I'll be briefly talking about one particular way. It's called KLM GOMS. Okay, so KLM means keystroke level model, and GOMS stand for goals, operators, methods, and selection rules. Okay, so this particular technique is used to measure the efficiency component of a feature. Okay, so and like I gave the example previously, like you have various components, and among those, efficiency is one of the components which you can measure by using this particular technique, KLM GOMS. So what this particular technique provides is that the KLM means keystroke level model. It's basically a particular sheet of information where you have information on various timings. Now these timings were predefined by scientific community. So you have timings, and here you have various keystroke operations. So various keystroke means if you use a computer keyboard press, you have certain fixed timings defined like 0.3 millisecond. Similarly, if you have a mouse wheel up or down, so you have some timings defined. Again, if you access a drop down menu, you click and a drop down menu opens, so that particular time period is already defined. Okay, so you have this set of time periods already defined, and what you do is that you add all these timings for a particular method. Okay, you choose to do a particular task. Okay, so the KLM part define the different various keystrokes and their associated timings, and the GOMS define the goal with which you are actually the goal, operators, method, and selection rules with which actually you are trying to evaluate a particular user interface. For example, in this particular example, I gave the goal as that, and the goal is to buy a chart. Okay, so what are the operators? Operators means the various way how you can actually go to this particular page. So you need to arrive here the bestseller cert, okay, which got a 3.8 ratings. So there are different ways. So for example, method A involve actually typing the word cert, okay, then going to filters, then selecting certain brand, okay. So like that you have multiple operations, okay. So method A is like you have keystroke typing multiple times, then you have mouse wheel up and down, then you select a menu, click a checkbox, and then you select particular cert. The other way probably is going through this particular menu, all, then menu, and go to the cert option. Okay, so you have this menu, apparel, then men, casual, shirt. So like that you can actually in one go probably you can reach here, and when you uh, click here probably you will end up in the same page. So this is probably the other way of doing it. Now what KLM bombs allow you is to actually sum each of these timings based on your selection. You choose the appropriate timing from this particular chart, and then you add them. So at the end you will have a selection rule. Okay, I will choose the shortest time method. Okay, that means whichever method will take shortest amount of time, you will only select that particular method, and you will discard the other method. So this is an example. Like, so after doing this particular analysis, you will identify that okay, this particular operation takes less time, that's why this is the most appropriate method. That's why we need to provide some sort of fast access or some sort of shortcut to this particular method to the user. However, if someone wants very customized search, then only they will do this particular information. So that's the reason why a Amazon website provide multiple ways of doing a particular activity. So they provide easy selection menus so that one can easily buy a shirt. Okay, so those are like quick access menus. And if one needs custom shirts, like for example shirt with blue color, he can type here shirt with blue color, then probably his keystrokes will be more, but he will probably enter to that particular page in a more efficient way. Probably that will, in that case, this menu system will not be an effective process. Okay, so this is how KLM GOMS can be used to measure efficiency of a particular feature in user interface. Okay, so more details about such techniques will be provided in the subsequent lectures. So this is just the introductory session, that's why I just gave a simple example of a process where keystroke uh, are counted and their timings were added to identify the best probable feature. Okay, clear? Any doubts here? Okay. Okay, so finally, we are here. Like, in summary, what we understood is like what are the various scopes of usability engineering. So the very first scope is to incorporate. I'll start from here. So is to understand the requirement. Okay, requirement of a particular application. Okay, and then you define a set of uh, measurable goals. Okay, so when you do requirement analysis, you incorporate social as well as organizational aspects of the system development. That means you need to consider the user profiles, the scenario where the the application or the product will be used. Okay, so that's where the scope of usability engineering extends than the past scopes of usability back in that was there in back in 90s. And then after we do the requirement analysis and understand various user profiles and use case scenarios, we come up with some set of usability goals which must be addressed in the design. Okay, so next is the design of user interfaces, features and functions, and then we assess the design recursively and make the design changes. So that's basically the overall objectives or the scope of usability engineering. Okay, now the question comes into mind is like, how do you start usability engineering? Okay, so so when someone give you a project like, okay, we want a mobile application, okay, we want a banking application, so new banking application. So imagine the first time when someone wants to develop a banking application. So what course of actions they used to do? Okay, so for that purpose what we use is scenario based development. Okay, so what we require for usability engineering is scenario based development. That means we analyze a particular scenario and we try to address the issues, the requirements, and incorporate those as the design features, usability goals within our software development. Okay, okay. So for a mobile banking application, if you see, there are modular modules for transfer of money. Then there are option for account checking, and then you have options for messaging. Okay, so all these modular features are actually required based on scenario based requirements. Okay, so some of them are actually functional requirements for this application. For example, recharge. Okay, probably here recharge does not mean the mobile recharge, but this is means recharging probably your various accounts. For example, if you want to do a phone recharge. Okay, so those features have been incorporated in Axis Bank, but these are like secondary features. The primary features of a bank, actually in one actual bank, is transactions. Okay, so one needs to withdraw money, one needs to transfer money, and one needs to deposit money. Okay, okay. So when first time one try to gather this information, he or she would probably analyze what actually a banking scenario look like and how it operates. Okay, so here comes two concepts. One is use case scenarios and the other is user interaction scenarios. Okay, so can you do you know the differences? So what is the difference between use case scenarios and user interaction scenarios? Okay, so use case scenarios comes into picture when we are trying to develop a application having all possible functionalities. So it's it's a more generic term used to define various operations, various activities that has to be there in a banking application. Okay, so whenever we try to analyze a real scenario, real use case scenario of a, uh, what happens inside a bank, then probably we'll try to gather all sort of information, what all needs to be there in a mobile banking application. So that's what defined by use case scenarios. Okay. And this is more I mean, it's more generic in nature. So the way you define use case scenarios are like, okay, like withdraw, withdraw money, transfer money, then pay bills. Okay, so this is how you define various use case scenarios. Okay, in a mobile banking in a banking environment. The user interaction scenarios are more detailed one, and probably it is one instant. Okay, this is one instance of a use case scenario. For example, this tell you the story about what happens when a person try to withdraw money. Okay, so when a person try to withdraw money, what all set of action activities, mental processing a particular user perform, that all you try to understand using from a user interaction scenario. So this is more detailed, this is more detailed. Okay, user interaction scenarios, and it try to give information about all the elements involving like actors, various action, the environment in which that particular activity has been accomplished. So all those sort of information is provided in a user interaction scenarios. So the idea here is that when we set certain use case scenarios, these are like the uh, generic features or generic use case functionalities that needs to be incorporated. Then you do individual user interaction scenario for these individual features, and where you in detail try to analyze all sort of requirements that a user need to achieve various activities. Okay, so let me give you an example here. So imagine a office environment, a workspace of an accountant. Okay, so you want to see what are the use case scenario, what is for a account, for accounting. Okay, so you need to explore the use case scenario of of a, sorry, not use case scenario in, let me clarify this. Okay, you want to analyze the user interaction scenario of using a particular spreadsheet. Okay, so now in a office environment where there are account section, there are several accountants were involved in various departmental activities. So you want to explore for a particular user how he perform or how he uses a particular application in his day-to-day activities. Okay, so for that we need to first understand what are the various elements, okay, various elements in a user interaction scenario. Okay, so probably you have seen, you have referred the lectures, week 2 lectures, where you were informed about these various elements like setting, okay, which define the environment, the the situational details that motivate and explain and the goal action. For example, in this particular case, it is the office within which and like this particular person works. Okay, so it also uh, deals, it's talk about all sort of tools, the surrounding environment, the people associated with him, and as a designer our goal is to capture all these details from a contextual inquiry. Okay, the second element in a contextual inquiry process is no, sorry, the second element of a user interaction scenario is actors. So we try to get information on all sort of people who are involved in that particular scenario or activity. So here we try to gather information about humans interacting with computers and other elements, other setting, and also their personal characteristics, okay, their demographic information. So here in this particular case, we are talking about the accountant which is using a spreadsheet. Okay. Then we try to capture information about the goals. Okay, the particular goals he have, and this kind of activities he do in his daily life. Okay, so these are the effects that on the situation that motivate a particular action. For example, if a particular accountant is asked to compare the budget data, then that became a goal for him. Okay, so probably in a particular daytime when you were asked to, you know, investigate that particular context, that particular user interaction scenario, probably he or she may be involved in, comparing the budget data. Okay, so that became the task goal for that particular person. Then there are certain activities which involve, which are like mental in nature. Okay, that means the mental activity that direct that particular uh, person to convert the goal into behavior. So that means the particular goal is to compare budget data, so he first starts planning. Okay, so you need to capture all those information during that user interaction scenario. So when you do, so from that particular user interaction scenario, a designer should be able to identify the planning that's going inside that person head. Okay, so for example, that person understand his goal, and then he tried opening a document, okay, who will give access to the particular budget information. Okay, then he realized that particular window actually opened very big, and then he resized that particular window and make room for another. So basically what happens, like when he tries to compare two different budget data, so he probably he tried to keep two spreadsheet, okay, by resizing them within the same, LCD space, monitor space. Okay, so that particular activity is only what you can visualize, but it's difficult for you to understand what actually is going inside that person's minds. But as a user usability expert or as a designer, your goal is to also understand how his decisions move, like how he make those decisions. For example, while opening that particular spreadsheet, he may have actually gone through multiple mental activities, okay, mental operations, and then finally arrive at that particular step where he opened a particular Excel sheet. So visually, like visibly, these are not like visible or available for someone who is actually watching that particular action, but there are ways how one can capture this information. So those techniques you will learn in the subsequent lectures. So techniques like think aloud protocol can be used to uh, to actually record what are the various mental operations a particular person do before arriving at his final set of activities. Okay, so those planning, okay, also come into picture. So you want to capture those planning information also when through a contextual inquiry, when you try to understand a user interaction scenario. Similarly, what happens, like when he makes certain plans, he also makes certain evaluation. The person make those judgments, okay, in his mind, and then he do certain actions. For example, if a window is too large and that actually hide the other window, then probably he will resize them accordingly. Similarly, if a window he is selecting, it border is indicated in a dark color, probably he will understand that this particular window is active. So those information that actually is processing inside that particular user's head, you need to capture all those information also. Okay, so these are like the mental operations or operations that we as a designer needs to capture, okay, to evaluate how we can minimize those. Okay, so because these leads to cognitive load in case a particular task is very difficult. Okay, okay, then we have actions which are like observable behavior. So when a particular document open, then that particular what he do, he will go and click his mouse to actually resize that particular window and position that. So those are visible information, okay, but these two are not visible, and there are techniques how you can actually capture those. Then events are again those actions which are produced by the computer as a feedback to the user action. Okay? For example, uh, when you select a particular Windows corner, probably the Windows would give a feedback. So feedback. So when he tries to select a particular window, probably there should be change in color, or there should be some change in the cursor look and shape, which will make him understand that okay, he is able to select that particular edge. Okay, so again, if he is pressing certain keys, if the key give him some sound, probably those are the feedbacks that are required. So in a particular contextual inquiry where you are involved in the inquiry of a user interaction scenario, you try to capture all such elements, okay, and later based on these various elements you decide on the various requirements. Okay, and there are different techniques. If the elements are visible, then you can record them, you can actually record them with videography, photography. But if there are elements which are not visible, like the planning, actual planning, and the evaluation, which are mental operations, which are so quick that it is very difficult for a person to actually notice those or record those. So for that, we use different techniques to capture those mental operations. Okay, and for others, like setting, we can use simply photography and other ways like interviews, or questioning, to gather information. Okay, on those. Okay, so let me give you a example for you guys. Okay, so now you need to help me in identifying these key elements. Okay, so here is a scenario. Suppose this is a medical device. This is a particular medical device which is used for wound healing. Okay, so the function of this particular this thing is wound healing, and you have a user interface having a graphical user interface and a tactile button interface. Okay, and the scenario is here is that you try to understand how. So as I told you, user interactions scenario is one instance of a use case scenario. So what are the various use case scenario of a wound healing device? Probably, the various modes. So probably you have modes for wound healing, wound diagnostics. Okay, so these are examples. So probably it has two use case scenarios. Okay, but you want to understand one particular instance of wound, like that is wound healing, and for that you immersed as a contextual inquiry in a scenario where you will try to analyze a user interaction scenarios. So your user interaction scenario involve, what you see is that two soldiers are actually trying to help a wounded soldier who is having some sort of facial wound, and they are trying to use this particular uh, device. Okay, now tell me what you will capture. Okay, now you need to understand what all you need to capture, what elements you need to capture. Okay, so how do you define the setting? So you can use the chat box, or you can directly interact with me over microphone. So what do you think are the setting, how you define the setting? Okay, so here if I say setting means it is like a war scenario. Okay, war scenario, and it's like a uh, you try to define the scenario like it's like a building, and you know it is outside, so it is like like in a war zone. So it is so no support of no medical support, no medical support. Okay, and two-person helping a wounded person. Okay, so that's the setting. So that's how you define a particular setting. So from this setting you later try to understand like what happens like in a war, like what are the resources, what sort of resources are available. So when you are designing a particular interface, understanding the setting is vital, because you probably will know that if it's a outside scenario, it's a war scenario, probably your device needs to be a battery operated device. Okay, so probably you cannot access to any wall mounted power supply. So all those decisions probably uh, can be considered when you try to understand the setting. Okay, so this is how you define your setting. Okay, then you try to define what are the actors. Okay, so actors here are like soldiers. So so one probably is a medic soldier, one normal soldier, and one is wounded soldier, right? And if I try to see the personal characteristics, like one is like he's like a warrior soldier, one is like a doctor. Okay, Now task goal. So what is the task? So here the situation is that a particular person get probably encountered some explosion, and he is wounded. So the goal is to give him some fast relief, and then try to take care, manage the wound. Okay, so the goal here is to manage the wound. Okay, then planning. See, the planning actions now are like mental operations. Like when a particular the this particular medic soldier decide like what particular therapy needs to be provided, all these things probably is going inside his mind. Probably he may think, okay, his wound is very deep, so I need to give the therapy three, and probably the duration should be 30 minutes, and particular pressure level should be 650. Like these are the examples. Like all this mental processing actually happening inside the brain, and you need to capture those by two like different ways are there, like mental, like capturing mental operations is vital for usability engineering. And there are ways how you can do it, like there are think a lot protocol. There are also different ways, like how you can capture those, like you can also see uh, his actions. Okay, and then how the particular person make those decisions. Okay, so for example, he have this many he has a planning. Okay, like okay, for this particular wound I need to give him this particular therapy, and then I need to select this. So next thing is like how uh, he will interpret this particular interface, because this is his clinical knowledge. Okay, which is like based on the wound, he will know that okay, and this particular therapy is required, that much pressure is required, that much time is required. But now he encountered the interface which is this. Okay, now he need to figure out how to select those particular things. So he again will have some sort of mental activities. So there are again similar ways like how you can capture those mental activities, and then you capture the activities. So whatever buttons he press, okay, whatever setting he put, all those informations will be visible. Okay, so for example, after, if you see the video of this person giving this particular therapy, you can see like okay, he actually set, he pressed this particular button three times, and then he set this to 650 for 30 minutes. Then he selected that particular therapy. So these information can be seen visually. Okay, so now usability engineering not only uh, try to capture this visual information, but also in usability engineering we try to capture this mental operation, so that we can reduce those mental operations and give the most simplistic way of performing that particular action. So these are important. That's why I'm giving this particular example to understand like how a particular context changes and the certain requirements. Similar events like in a war scenario, when there are loud sounds outside. Okay, there are loud sound outside, so it's not always easy to hear a small beep sound, which probably is easy to hear in a closed room environment. So the kind of indication that particular system needs to provide needs to be really loud, or needs to be something else, or something like vibration or some color change, so that if one cannot hear that small sound, then probably by seeing this change in color, probably he will notice that okay, that particular therapy is active, or that particular there are some issues with the running status. Okay, so those information, those feedback needs to be planned accordingly. So you need to again understand. So when you are trying to understand these various events and that has been produced by computers, so you need to understand like what sort of features one needs to deliver, like one as a feedback. Okay. Hope this is clear. So any doubt? Okay.
No,
Uh,
sir.
okay. So let's just change this in scenario. Okay. Now the same device. Now use case scenario. See, the difference between use case scenario and user interaction scenario is that now the device have the same use case scenarios. It has the uh, functionality of two therapies. Okay, therapy 1, probably therapy 2, or therapy 3. Okay, so different ways how the device can be used. But now you want to understand like what all needs to be there is a user interface when you actually try to use this particular device in a hospital, in a clinical environment. So now user interaction scenario probably will try to analyze a particular use case, specific use case or particular therapy in a hospital setting. So again, now you try to capture the elements of a user interaction scenario via contextual inquiry. So contextual inquiry means what are the various techniques, like different techniques you use to capture or record those information. Okay, so now let's tell me like what how do you define the setting? Okay, so setting is now the setting changes, like it's not a war scenario, now it's like a medical scenario. So it's a medical hospital. Probably, there is a army officer, so it's like a army hospital, probably. Army hospital. Then probably see, it's does not look like a very uh, high profile hospital. Probably it's a government setting hospital. Okay, and the wound is taken care by some nurse. Okay, so nurse is caring a wound. So that's the particular setting. That's how you define. Okay. Next is, what are the actors? Who are the actors? So the actors is the patient having a some issue with his foot foot wound. Okay, and the nurse and the army officer. So this is how I try to see the actors. Probably when you will be actually in the scenario, probably you will have different information. But that's how I'm trying to define just by looking at the picture. Now task goal. Now here the scenario is a bit different. This person is having not having some sort of acute wound. Probably it's not some sort of burn or fatal injury like the previous one. So probably now the goal is to select a particular therapy, okay, which is not the same as this particular therapy. So here probably you say, okay, and that particular, so the goal is to heal wound, which is probably a chronic wound. So the person probably brought back from war scenario, or probably he's just a mm, usual person, non-army personnel, who is having some sort of wound, and now he is getting treatment in a army hospital. Okay, so that can be a scenario. So the task is to heal his chronic wound. Now planning. Now based on now the nurse, the wound healing nurse is analyzing that particular wound site, and she's taking certain mental decisions, like okay, by looking at the wound site, probably she is thinking like, okay, this is infected, okay, and then needs cleaning, and then needs debridement, and then therapy 1 needs to be implemented. Okay, now this is like his thought process, which we again try to capture through our usability, like contextual inquiry technique, particular contextual inquiry technique for capturing mental activities. And the next activities again, after see the user interface, now this set of mental activity that goes through her mind, like how she will be selecting that particular, how she will be performing that particular tasks, activities, and what sort of, how she will select that particular therapy. So here again she will go through various mental operations, and then finally she will do the actions. So in for actions, she will press particular mode button, so mode two times, then press start. Okay, so this is what is visible. So you can record this information which are which are visible. Then since this is a like hospital environment, probably the system will indicate start by just displaying a running status or giving a small beep sound. Okay, like intermittent beep sound, like beep beep beep, like that. Or in case there are some emergency, the system can give a long beep sound. Okay, so those kind of interactions are acceptable in a hospital setting, but the same are not acceptable in a war zone when the environment is very noisy. So that's the difference between use case scenario and user interaction scenarios. Although a particular device or application uh, um, design goal may have same use case scenarios, however, when we try to analyze user interaction scenarios, we may actually come across various different requirements, set of requirements. So that's the reason why we give importance to user interaction scenarios in the context of usability engineering. So I hope this is clear, right? So any doubt? Okay. Okay. So the last topic of today's class. So finally, I'll discuss here is the scenario-based development framework. So basically, this is a particular design process or a framework where we take care of various usability engineering aspects of software development. So this particular framework comprised of three main stages. Okay, and for each stages we mainly develop, we mainly consider scenarios. So first we analyze problem scenarios. So the first stage is analyzing the problem scenario. So now problem scenarios, we gather information from our user interaction scenarios by doing field studies and by analysis of stakeholders. So analysis of stakeholders, field studies means we are considering user interaction scenarios and use case scenarios. Okay, there can be multiple use case scenarios, and then for each we can again conduct multiple user interaction scenarios. Then we analyze the problem scenarios from current practices. So for example, in this particular last example, for this particular clinical scenario, there are some sort of standard practice, right, or some competitive products which are already available. So you try to understand what sort of issues the standard procedure have or the competitive products have. Okay. So this is like a current standard process or competitive products. So this is same for anything, like if you are developing even a mobile application like a banking application, so you first try to analyze what are the problem scenarios. So problem scenarios you analyze by first doing the user, for understanding the use case scenarios, That means what are the various features that the particular application require, and then you study the use case scenarios. User interaction scenario. That means what will happen when a particular when a user or a stakeholder will use a particular feature. So you will do that particular contextual inquiry. So there are different techniques, and you try to gather all those information about all those elements. Okay, and after you analyze those, okay, and you also incorporate the competitive products. So in case medical products, it is competitive medical products. In case it is a banking application, it is like competitive other banks application. And also standard procedure, which is probably for medical device, it is the standard wound dressing. And for a mobile banking application, it is like the physical banking the method. Okay, so after the analysis process, you come to the design phase. Okay, so once you understand the problem scenarios, you actually here come up with set of requirements. And next what you do is like you design various activity scenarios. Now here you plan how the user will perform certain activities. Okay, so you design the activity scenarios, then you design the information scenarios, like what sort of information and how the person will get those information. And then you define the interaction scenarios. So for this particular medical device, if I say designing activity scenarios means activity wise, it user can select therapy and run therapy. Okay, and change therapy or configure therapy. So those are activities. Information scenarios means what all sort of informations he will be requiring as a scenario in this particular scenario. Okay, similarly interaction scenarios, how this particular therapies will be implemented. So all those scenarios will be designed, okay, in the design phase. And this will be an iterative process either from two perspective. One is by considering the previous guidelines or historical scientific theory on information technology or human computer interaction theories or heuristics. You try to improvise your design, or you define some set of usability goals, okay, based on your requirements, and you try to uh, iterate your design based on those usability claims. Okay, once you achieve all these things and in an optimal way, you move to the prototyping phase. So you start with first with low fidelity prototypes, and then you evaluate those. So basically in the prototyping and evaluation phase, you first set a set of usability specifications. So these are the specification which your prototype will deliver, or based on what you will be evaluating your prototype. Okay, and based on this particular usability specification, you can evaluate your design. Okay, so again there are two different techniques. One is iterative, which is basically you iteratively optimize the design and change the specifications and then try to optimize the system parameters. Okay, and the other way is summative, where uh, based on all sort of matrices you once selected as usability specification, you sum all those. Like for example, in a particular design, for example design one, you said like specification wise the for a particular feature, for example the execution time is 3 seconds. Okay, then okay, number of steps are like three, and when you add all these string you have a final score of 14. Similarly in the new design, if design 2, if you can get a lower number For example, if it is 2 second, 3 second like that, and you get a lower number, probably you will have a better, system. So this is how you do summative evaluation. So this is basically aggregating all the features based on certain scale you choose, and you choose the scale in such a way that additive sum of that those scores will help you determine the particular design. Okay, so any doubt? So that's the end of today's class. Okay, okay, so thank you. So if you have any query, please feel free to ask. So you can directly interact with me or use the chat window. Okay. So the next class will be in the next week, next Tuesday. So be present, and I'll try to cover you some of the important concepts which are not actually there in the lecture videos. So the live sessions will be more practical and more applied in nature. And I'll try to give you examples to clarify some of those doubts. So thank you for attending the class. Okay, so I'll leave here.
Thank you, sir.